This isn't theory, this is real design decisions from real projects that could save you some serious money. Okay, let's start with something completely random. Stairs. More specifically, escape stairs. You don't really use escape stairs apart from there's a fire escaping. Okay, so you might use it maybe if it's an office or apartment, people might use it for the first couple of floors. But apart from that, they're not really used. People use elevators or lifts. It's the difference between like a feature stair and escape stairs. You don't need to waste money putting floor tiles on an escape stair that nobody uses. You can just leave it concrete. I remember the time I was 16. My parents took me to New York and we stayed in this room. It was on the 50th floor or something. And when we went to breakfast, because I was a little kid, I was excited. I wanted to walk down the whole stairs. I remember to this day, that stair didn't have a finish on it. It was just concrete. So you're walking around the hotel, it's like nice carpet, whatever. And then you go to this random escape stairs, which was difficult to find. And it's just concrete. And even that balustrade, you don't need anything fancy. Just put a metal one there. If you really need to, you just put them in the first couple of floors. Or one of my recent projects, you get like well rating, promote health and stuff like that. You can dedicate one stair to be used and then you could put the finishes on that one, and then the other one can be just purely for escape. So especially, it's like, imagine if it's a skyscraper, you think Burj Khalifa even will have tiles on their stairs, so that'll save you some money. And the next one is put all your expensive shit at the entrance or at the front, or where you can see it. Don't spend money at the back when you're not going to see the building. There's projects I've worked on where there's certain angles of the building or even the rear, nobody's going to see it. I know you're creating a work of art or something, but in reality, no one's going to see that side of the building, so you don't really need to do much on it. You can just paint it, you can just put some basic windows, or if you need shading or something. But if you've got expensive materials, if you've got facade cladding or something like that, stone, if you want to put stone on the building, put it up where people can see it. You don't need to continue putting it everywhere. One project I'm working on, so we put tiles at the front on the facade, but then we'll put tiles on the side slightly, but the rest of the building will just be painted grey to match the tiles. So you can do stuff like that. Like, no one's really going to notice stuff. And if it's high up as well, sometimes you don't see it. So if it's like an apartment building, say like 5 or 10 stories, then you can put some stone just around the entrance, ground floor, where people will appreciate it and see it. There's no point putting stone like everywhere. You just put it like certain areas. So yeah, other areas like reception, where all the public areas, put all your money there. Don't put it in hidden places. Back of house, delivery area. Don't put any finishes there. You don't need it. The next one is to build up. Now, I don't mean to build multi-stories, but like if you're doing a bungalow or something, like just one story, you might as well do another floor because you're paying for the foundations. If you're paying for the foundations, then it's not going to cost much more to build another floor. Okay, you'll need some more reinforcement or something in the foundations, but it'll be cheaper to add another floor than it is to like put another foundation on another house. So you build up if you can. And then the next one is the opposite. Basements. Try to avoid basements. Basements are expensive. All the digging and reinforcement and all the retaining walls in the basement, waterproofing, cut and fill, excavation, ventilation, all those things. So like basements, try to avoid them or make them as small as possible. There's a project I worked on recently. If you have a car park in a basement, if you want to really save some money, put it outside on ground floor or find some land nearby instead of putting the car park all underground. So sometimes it's cheaper to build up a car park and then put the building on top of the car park than it is to build the basement. So yeah, so try to avoid basements as much as you can. I know in reality you might not be able to, so they're just expensive. Next one is target the most dominant material by weight or cost or quantity and reduce. Normally where I live, it's the reinforced concrete, the structure that's the most heaviest and the most expensive. So we try to reduce the amount in the whole building. So you make the slabs as much as possible, reduce the columns as much as possible. That's normal engineering, but that's just an example of what to reduce. Like where you can, don't put RC reinforcement concrete walls everywhere. Do it out of like lightweight block work or something if you have to. So reduce the amount as much as you can. And this helps with sustainability as well as cost. The most dominant material, the heaviest one, that's usually the worst for the environment. And also the most expensive one is usually the most worst for the environment, not just cost as well. So take that and reduce it. Find out how much money you're paying for something. Just reduce the area. It's all about areas and reducing them. Next one is reduce the floor-to-floor height. Usually office buildings, commercial, they have a lot of services, so the floor-to-floor height is usually larger than something like residential, because sometimes you don't need as much service space. Usually where I live, it's 600 mil between the bottom of the beam and the ceiling. That's how much space you need. So you got that space for the services, you like HVAC, electrical and plumbing. You have dedicated zones for that. So if you have anything more than that, a waste really. So make sure you close the decision of how high you need your ceilings. If it's an apartment, you would probably like 2.8, or if you want a high tier, top tier office building or residential, you might want 3 meter ceiling. So that's considered top tier, and you've coordinated the services, then there's your floor to floor height. So you need to, that's why it's critical to get that right, so you're not wasting money on the floor to floor height. Sometimes you can do the ground floor. If you got entrance lobby or something, you make it higher, ground to first floor, you make that higher. But even 100 mil, even something small like that, multiplied across multiple floors, that's going to cost you a lot of money. You might be reducing the glass. If it's a glass facade, you're reducing the concrete, you're reducing everything. So reduce your floor-to-floor levels as much as you can. Right, the next one is make every square meter work. This is game changer for me, especially spaces that you're going to rent out. So if you've got a commercial office building or something, or even an apartment building, the rentable space that's actually going to be rented out where the client is going to make money, that's the essential piece you need to make as big as possible. But the areas that are not going to be rentable, so the communal spaces, you got to reduce that as much as you can. So a good standard rule of thumb for a commercial building is 80%. So you need 20% of the core area, the lifts and stairs and toilets and stuff. That's 20%, and then 80% is the rentable area. That's considered an efficient building. So anything more than that, you're wasting money. You're spending areas of floors that you're not really going to use. So it's all about the area of the building. Like, people don't understand. People ask me, like, how much does it cost to build me a house? Depends how big it's going to be. The size of the building is going to affect the cost. This is the basic early principles of costing a building. If you've got 100 square meters building, then it's going to be whatever the local rate by a builder charges per square meter. So that's how it works on the simplified way of costing a building. So the early costings involved in a design is just measuring how big it is in square meters and multiplying by $1,000 per square meter or whatever it is in the local area you're at. So, okay, it might depend on how luxurious the materials. Yeah, that has a lot to do with the price, but you still quantify the size of the buildings. Then you might say it's $1,000 per square meter for like an average building. If you want an extra high class building, then it'll be $1,200 per square meter. So that's how basic costing works. So reduce the size of the building as much as possible and prioritize the rentable space over the communal spaces that are not going to be rented out. So keep cores, circulation, stairs, toilets efficient. That's why like toilets in public buildings are often very small. You make them as small as possible. I do anyway, because it's more efficient that way. The next one is keep the structure simple. So simple grids. The standard thing we do for grids, because car parks usually dictate the size of the grids and the columns, because usually you've got a car park underneath a lot of buildings. So it's usually 8.4 meters by 8.4. Then you can get 3 car park spaces and you can rotate it. So that's quite a standard. Anything over, in our country anyway, where we use reinforced concrete beams, it's like 600 beam and 8.4 meters span. Usually that's the pretty much standard. or less than that. Once you can't really go up to like 9 meters. Once anything above 9 meters, the beam is going to change. The depth is going to get bigger, so that's when you're going to get odd sizes of beams, and then it's going to cost more money for beams, reinforcements, and it's not standardized, and like takes more time costs money and all that stuff. So regular grids, sensible spans, and avoid transfers. We always say if there's a transfer in a building, then it's usually bad design, really. Transfers is when you have columns come down and then you'll have a massive beam, say on level 1 or 2, and then the columns change or they move slightly. You're transferring the load to a different column. So we consider that bad. We try to avoid that as much as possible. Like some buildings, you have to do it like for instance, you might have an auditorium on one floor and the columns come down and then you have to divert the columns on that floor. Very rarely you do that. We usually try to avoid that. So that costs a lot of money because you have to put the hell of a big beam to take the load and rearrange all that and engineer it. So you try to avoid transfers as much as you can as well. I think I only worked on one project that had transferred, one of the early projects, but I've never done it since. We've always had troubles with it, and there was we had to add it's a nightmare. It didn't work very well. And also repetitive structure and systems creates more efficiency, so that it's cheaper to build that way. Next one is landscape. The amount of times I've seen people when they have a site, especially here where I work, and they have the site or they just bought land and they get rid of everything straight away or put concrete down. It's like, you don't need concrete on ground unless you need parking or something. Just keep it open, keep the landscape, keep the trees. The ground floor, the landscape area, you're wasting money with your concrete on the ground floor. Why do you want to just take your site and just put concrete on ground floor? There's no point in it unless you've got car parking. I try to minimize the amount of floor on ground floor. So if you've got a path to a building, you just put the path. If you've got a roadway with a parking space, just do the part. The rest of it, just leave it earth and garden. That's the best thing about projects usually is the garden, the trees and the landscaping. So leave that on ground floor as much as you can. And don't just bulldozer it down and put concrete. And trees are like the best thing about the site, so try to keep them as much as possible and save some money not putting the concrete and keeping the trees as to make the building look better. The next one is standardize and repeat, especially stuff like doors and windows. I'm not talking about there's a certain size, more efficient size for the window manufacturer according to the glass. Yeah, there's that as well. But I'm more talking about don't have one window 1 meter wide, another 5 windows 1.2 meter wide, and change all the sizes. It's like a bloody headache. It takes time doing all that stuff and to manufacture all that. So keep them the same size. Keep it modular, especially with details and like facade details, or you got something like you've got a nice feature on a building you want to keep. Like get that right. Tectonics. It's like you get one element, design it, and then you just repeat it. And then it looks like one big element as it goes repeated together. Once you got that right, they do a sample mock-up on site, then you can repeat. That's how it works on site. They'll do things stage by stage. So they'll get a window and then they'll do all the windows, then they'll get the doors, do all the doors, then they'll get all the coping for a roof or a wall, and then they'll build that, and then they'll repeat all the bits and build it. They'll do it by material parts. So they get one part and then repeat it and put it on, and get another part and put it on. So standardize your materials, then repeat them. Don't have random sizes for things. I mean, we talked about standardizing structure, but even rooms, if you're going to have a repeated room, don't make one room slightly bigger than the other. Just repeat the size if you can, because furnishing it'll be just a nightmare. You'll get a different size bit of furniture for another bit, and that bit, if you have to do site measured furniture, or there'll be tiles for one, you'll have to cut. Just repeat rooms if you can as well. Repeating elements really is the way forward. Next one is keep building form simple. The amount of times nowadays I see architects doing curves for no bloody reason. You do even in a corridor around a corner to the toilet, they curve in the wall. Do you know how much of a pain that is? Got a curved wall. What happens if you have to put tiles on that? What happens if you have to put skirting around that? What happens if there's going to be a ceiling around that? That all needs to curve with it as well. It's a pain in the arse. There's no point putting curves on building unless you've got a valid reason to do it. And if you do, then just minimise the amount of curves. Don't put curves everywhere. It's a bloody nightmare. This is the practical side of architecture. Like, they don't tell you this at university. It's like, just put curves everywhere. In reality, not everyone's Zaha Hadid, you know. Cantilevers, well, I'm a bit famous for my cantilevers. I get in trouble for that. Like, don't be extreme. I think the cantilever is like a third of the length, the standard rule of thumb. So like if you got a overhang, like it's like a third of the length of the overhang that you can do. So yeah, so reduce them and reduce the complicated junctions. Basically just keep things simple, really. That's all there is to it. The next one is use practical materials. Usually if you're going to talk about sustainability, everyone talks about use local materials. Okay, yeah, use local materials, but use practical materials. There's basically four. Where I work, you have to import practically everything. So there's only like 4 materials you can practically use that are cheap and efficient and practical, really, and long lasting. That's why people use them. Concrete is one of them. The other one is plaster. The third one is like stone, which is used sparingly. And then there's timber, mostly used for internal. Oh, there's steel as well, mild steel. That's usually local available as well, used for gates, railings, and things like that. That's another good one. Okay, it'll rust, but you'll just have to paint it every like 4 or 5 years. Okay, you can treat it. There's galvanized steel, there's stainless steel, but again, they're going to be more expensive. So the basic one is mild steel, painted. Okay, some countries use more plasterboard or dry line stud walls, dry walls, stud partitions. Some countries use that, but where we live, we just mostly use blockwork because it's quick and efficient, and everyone can do it quickly. We don't piss around with drywall systems much in Tanzania. That's the other thing. When I worked in UK, architects would spend bloody days, weeks, months drawing all the drywalls. What plasterboard is it? 2 layers, 3 layers, 1 layer, acoustic layer on one side, a damp-proof plasterboard layer on the other side, stud in the middle. How big's a stud? Gone are my days when I was spending 2 weeks drawing partition plans, specifying all the plasterboards and all that stuff. Never again. I don't waste my time with that shit anymore. Then you get like aluminium as well. A lot of that sometimes is imported. Use that for windows. And we have even glass. If you've got double glazing, that's imported here. So there's a bunch of materials like that, like paint as well, which is local. So just stick with the basic palette if you can, and like anything else is going to be a pain in the ass. If you live in China or something, everything's available. You got everything for you. But like, if you want to keep it back to basics and the most cheap and efficient building there is, use those materials. It's as simple as that. Okay, it might vary slightly at other countries. I'm pretty sure those materials I just mentioned are the basic ones that you can use on all buildings that would probably be the cheapest. In fact, if you really want to go cheap, that's why you see so many buildings nowadays are just finished concrete. The cheapest you can do is basically cheapest concrete. I know you got all this stick about, oh, it's not sustainable, but the amount of cement in concrete is relatively small. It's not that bad. The reason why people use concrete is because there's no other material that's as long-lasting and durable as concrete. It's also quick and easily available. If you use something like mud or timber, it's not going to last long. So that's why people use concrete, because it's the best material. Okay, next one is reduce service runs as much as possible. That's why you need to lock out the room locations early. So where's the LV room? Where's the transformer room? You know, electricity comes in, that needs to be converted in the transformer. Where's the transformer on your site? And then it goes to a low voltage room after that. So low voltage room should be centrally located somewhere in the building, so you don't have to waste money with the cables. There's a lot of money wastage running cables across ground floor on the building to another part of the site. You locate these service rooms, decent locations, so cables can be expensive if you're running them. So make electrical cable runs as short as possible. And then there's plumbing. Of course, you know, you put the toilets above each other, obviously, and then you hand toilets on both sides to reduce the plumbing. You must know that. That's pretty obvious. You don't want so many pipes going across and everything. You want them quickly going down and servicing the building. Oops. Reducing the pipes as much as possible. And don't forget, when you have a service duct or riser, it goes throughout the whole building. It doesn't suddenly stop. It goes all the way to the top and it goes all the way to the bottom. It's simple logic, really. Whatever comes up must come down. That's why at the beginning of the project, you should always ask the engineers for a mechanical, electrical and plumbing riser and equipment schedule, so you know where all these things are going to be and where you locate all the MEP rooms, generators and things like that. So they're in a central location that you don't have to route things long distances. And that moves on nicely to the next one, which is get big decisions right early. That's why you need an architect to plan the building early on, so all the rooms, all the mechanical, electrical rooms, all the spaces that you want is all on the plan in the correct location. You're not screwing around with this later on, because that's going to cause more time, extra costs that hasn't been budgeted. Variations in the design are a nightmare and they cost time, money and the headaches, and more consultants that have to get involved, and then you'll have to pay more money as well. And that's the concept design. Those are the big decisions you lock in and sign off, the client signs off. Because if you make those decisions later on, they're going to have some drastic changes. Changing one little thing, like moving a wall later, like 1 meter, screws up everything. It doesn't. You don't go halfway through site and then you start moving a wall or moving a room. It's a nightmare. The services all have to change. The structure affects the structure. You have to change that. Like mechanical, ceiling will change, doors might change, tiles might change. You might have ordered all the tiles, you might have ordered this, and you're changing all that, and it'll just be a logistical nightmare. So you got to get the big decisions right early. Honestly, this list could go on and on. For more practical architecture tips, subscribe here, and there's some videos here called Architecture Explained. You got more videos like this, you can click that as well. And I'll see you over there.